Typically, if I'm going to either cold call on an organization or they're going to call me, the process is fairly similar either way. The first thing that has to be done is we need to get a feel for whether or not there's any viable projects there. We'll go out, I'll go out and meet with the customer and get a sense for how much they're spending, what their costs per square foot are, and how much their gas per square foot, their electric per square foot consumption is on an annual basis. From that, we can get a pretty good idea based on the type of facility they're operating as to whether or not they're in line with where they could be or if they're way over on their energy budget. If they are way over, then the next step is to engage one of the performance contractors that we have on our contract with the state, or ask all four to come out and prepare a preliminary audit. We'll go through a process where we walk all the facility buildings, gather up several years worth of utility bills, interview some key people on the staff, then take a couple of weeks to put together what I call your 10,000 foot altitude view of the landscape. It is just an estimate. It's very preliminary, but it's a pretty useful tool to allow the customer to know whether or not they actually could have a viable project. Based on the results of those preliminary audits, the customer will select one of the ESCOs to go forward to produce the investment grade audit. The investment grade audit will actually get in great detail what the potential energy conservation measures are at that site. In any event, after the detailed analysis is done, then the performance contractor essentially provides the customer with a list of measures that need to be implemented, and they're prioritized in accordance with their economic viability. At that point, we work, the customer, myself, and the ESCO work together to develop an end product, a list of those projects that they want to include in their performance contract. And generally we put in all of what I call the low-hanging fruit, the short payback stuff, and use that as a lever to help buy down, if I could use that phrase, to buy down the cost of the long-term things. We use the lighting and the temperature controls and some of the other quick payback things to help pay for things like chillers and boilers and repairing infrastructure, things that typically take a very long time to pay back. We work out a project that's going to suit the customer's needs and it's going to pay for itself. Then we go to the next step, in which we actually go out, obtain the money by one of the private lending agencies, and begin to implement the project. The performance contractor has ownership in it. They guarantee the savings, they guarantee the results, and they measure, they verify the savings of the various measures that they have implemented, actually go out, put meters on, do other testing to determine the improvements in efficiency, and if they're short a little bit, then the energy performance contractor makes up the difference. They are actually, by contract, required to guarantee that there will be enough savings produced from their improvements to pay back the lease. There is a pretty good body of knowledge out there that's available for the public through the Department of Energy's Energy Information Agency, which allows you to compare your facility to nationwide averages and also regional averages for similar facilities in your area of similar sizes. That's one of the ways that we do it, is we compare the energy density, the watts per square foot or the MCF per square foot, therms per square foot on an annual basis that a building is consuming. We'll compare that with what a national average for that particular type of facility in that size in our region should be. Another thing that we do when we're doing our walkthrough is we're actually gathering information. We will look at the types of lights that are installed, and usually that's a real good indicator, just to go up and look inside one of the fluorescent light fixtures. The newer technology is the T8 systems with the electronic ballast. It's very easy to compare that just by looking to see if you've got the new technology in there. Typically, we find that most of the buildings out there, if they are still using the old T12 fluorescent lamps, if they haven't taken that, which is the first step, they haven't taken any other steps. Is there a cutoff date? If it was built beyond a certain year, we shouldn't spend our time analyzing it? The answer to that is no. The reason is most of the construction for public buildings is done using the low bid process. The low bid process almost guarantees that the end result is not going to be as efficient as it could have been had the design been done using a life cycle cost analysis. Life cycle cost analysis will mandate that the building will cost more, and all of the equipment to support the building is going to cost more initially. But over the life of the building or the life of the equipment, the cost to operate it over that lifespan is going to be substantially less. The mindset of people that are in charge of building new buildings, and pretty much the way the laws are, is that the low bid process pretty much rules. With the limited budgets that we have, the low bid process pretty much rules what gets constructed. We can go into a brand new building, brand new, and generally eke out some savings there, even if it's not replacing any equipment, just going in and fine-tuning what's been installed. That low bid contractor, his goal is to get that stuff installed and to get off the job and move on to the next one. They're not typically going to spend the time that it takes to really dial in and fine-tune all of the controls that go into making a building operate efficiently. Ideally, we'd like to be able to address every building, every public building that we have come before us that wants help. But the truth of the matter is there is economy to scale, and a building does have to be in a certain square footage in order to be economically viable to spend any time and come in and do engineering on, and to get a contractor to be interested in doing the work on. I think the smallest building that we've ever analyzed or had get involved in the program was pretty much a single, not exactly a single room, but a building that had been a supermarket that had been recycled into a state building. I believe it was on the order of 8,000 or 10,000 square foot, and it was marginal as to whether or not it was really economically viable to spend our time to go in and do work at that building. 10,000 square foot is on the low end, I would say. We're currently involved in a building that's 40,000 square foot. That's fairly good size, but it's one building. They have one meter, one gas meter, one electric meter, one bill, and it's one agency in there, and that's going to turn into a pretty nice project. It's an older building. The closeout meetings after we've completed a project are enjoyable. I like doing the follow-ups after the customer's had the project operating for 3 months or 6 months or a year. I like going to the follow-ups to find out how the project is working for them. And generally, those are always very pleasant meetings. The customers typically are very happy with the results. We've had a lot of commentary on how much work actually gets done in such a short period of time with such a limited impact on the day-to-day operation of the business of the school, for example, or the university. One of our universities commented it was like they came in during the night, did all this work when nobody was around, and when we got there the next morning it was all done, and we'd never even noticed that they had been there, other than our utility bills went down. That's pretty satisfying.